Module 8, Problem Set 3. How many moles of potassium sulfide are formed from a reaction of 12.3 grams of potassium hydroxide with excess hydrosulfuric acid? We're told the other product of that reaction is liquid water. Okay, so let's begin by coming up with the chemical formulas for the reactants and products involved. Okay, one of our reactants was potassium hydroxide. Potassium, a group 1A alkali metal, is a cation, will have a +1 charge. Hydroxide, one of our polyatomic anions, carries a -1 charge. So potassium hydroxide in aqueous solution. We're reacting with excess hydrosulfuric acid. Okay, don't get confused. This is not sulfuric acid. Hydrosulfuric acid would involve hydrogen with just sulfur. So my chemical formula here would be H2S in aqueous solution. We're told we made potassium sulfide, K plus S2 minus, so K2S. And the other product was simply liquid water. Okay, so we've got our appropriate reactants and products. Now let's set about balancing this chemical equation. Okay, we've got 2 hydrogens, 2 potassium. To get 2 potassium on reactant side, I'll need a stoichiometric coefficient of 2 there. I've got now 2 plus 2 for 4 hydrogens. I'll need a stoichiometric coefficient 2 there. And if we double check 2 potassium, I've got 2 oxygen, 2 oxygen, 4 hydrogen, 4 hydrogen, 1 sulfur, 1 sulfur. Okay, now let's do the required stoichiometry. Here we're told we had 12.3 grams of the potassium hydroxide, 12.3 grams of the potassium hydroxide. In talking through the steps of the algorithm here, I'm going to take that mass of potassium hydroxide, convert to moles. I'll then convert moles of potassium hydroxide to moles of product potassium sulfide, and that answers my question. Okay, so I'll need to know the molar mass of the potassium hydroxide, atomic mass of potassium plus that of hydrogen plus that of oxygen. We get 56.105 grams per mole of potassium hydroxide. I want to convert moles of potassium hydroxide to moles of potassium sulfide. 2 moles of potassium hydroxide required to form 1 mole of potassium sulfide. Mass canceled mass, moles of potassium hydroxide canceled moles of potassium hydroxide. I'm left with my desired result, moles of potassium sulfide. All right, I do that prescribed arithmetic and I get 0.110 moles. Let's try another one. All right, a balanced chemical equation in aqueous solution of potassium sulfate with barium chloride forming potassium chloride and solid barium sulfate. Okay, again, let's come up with the appropriate chemical formulas for the reactants and products involved. We're told we had potassium sulfate, K plus SO4 2 minus. I would make this compound in aqueous solution. Barium chloride, on the periodic table, barium is in group 2A. It is an alkaline earth metal, so Ba2 plus, chloride Cl minus, BaCl2 in aqueous solution. And we're told we make potassium chloride, so K plus Cl minus KCl in aqueous solution, and solid barium sulfate. Barium and sulfate, these would also exist in a 1-to-1 ratio. Okay, let's turn this into a balanced chemical equation now. And if we look at where we need stoichiometric coefficients, 2 potassium here, I'm going to need a 2 there. I've got 1 sulfate, 1 barium, 2 chloride. I now have 2 chloride, so it is balanced.